Hi, this is Harish. Today I am ready to explain applications of linear algebra in information technology. What is linear algebra? Linear algebra is a branch of mathematics concerning linear equations such as a1x1 plus a2x2 plus and so on an xn equals to b. Linear functions such as x1, x2 and so on xn, a1 x1 plus a2 x2 plus and so on an xn and their representations through matrices and vectors. Why linear algebra is important? Linear algebra is vital in multiple areas of science in general because linear equations are so easy to solve practically every area of modern science. It converts large number of problems to matrix and thus we can solve the matrix. Linear algebra in its field. Linear algebra in information technology can broadly divided into two categories. Linear algebra for spatial quantities. Here you are dealing with two to three or four two-dimensional vectors and you are concerned with rotations, projections and other matrix operations that have some spatial interpretation. This is the kind of linear algebra that comes up. For example, in computer graphics or physical simulations, linear algebra for statistics. Here you are dealing with vectors in high dimensional spaces that have no particular spatial interpretation and you are interested in matrix decompositions and so on. This domain includes signal processing, statistical machine learning and compressing. Objectives. Importance of linear algebra. Graph theory, network models, cryptography, computer graphics, MATLAB programming. Graph theory. Example, given a directed graph G as follows. For directed graph, we have to find out the adjacency matrix. For adjacency matrix, we have to write vertices in rows and columns. For example, take V1. For V1, adjacency vertices are V2 and V4. So we have to write V2 and V4 as 1 and remaining as 0. Similarly, all vertices we have to write and fill.
Hi, this is Henani. Now I'm going to explain about applications of linear algebra in information technology. Consider an undirected random graph of 8 vertices. The probability that there is an edge between a pair of vertices is 1 by 2. What is the expected number of unordered cycles of length 3? Network models. This model was developed to overcome the problem of hierarchical model. The network model is a database model conceived as a flexible way of representing object and their relationship. And here, supplier, part and color. ACME is paired with engine and wing, and engine is paired with black, and in supplier ACME and DELCO is there, and in part engine and wing is there, and color is black and blue. And here the image of centralized A, decentralized B and distributed C are given. Then cryptography. Encryption and decryption require the use of some secret information, usually referred to as key. Example, let us message to an encrypted B, like prepare to negotiate. We assign a number for each letter of the alphabet. Thus the message becomes prepare to negotiate. 16, 18, 5, 16, 1, and we have some numbers. Since we are using a 3 by 3 matrix, we break the unenumerated message above into a sequence of 3 by 1 vectors. And 16, 18, 5, 16, 1, 18, 5, 27, 20, 15, 27, 14, 20, 9 and 1, 25 and 27. These are some matrices, 3 into 3 matrices. By multiplying encoding matrix to this matrix, we will encrypt the message. Here 3 into 3 matrix contains minus 3, minus 3, minus 4, 0, 1, 1 and 4, 3, 4. And here 16, 16, 5, 15, 5, 20, 20, 18, 1, 27, 27, 7, 9, 15, 5, 18, 20, 14, 15, 1 and 27. And hereby we can solve this by multiplying minus 3 into 16 plus minus 3 into 18 plus minus 4 into 5. We can get minus 122. Unlike minus 3 into 16 and minus 3 into 1 and minus 4 into 18. We can get minus 23. Like this, we can solve this two columns and we can get the answer. Now, to decrypt the message, we have to multiply this matrix to inverse of encoding matrix. To the inverse of this encoding matrix, the decoding matrix is 1, 0, 1, 4, 4, 3, minus 4, minus 3 and minus 3. By multiplying again by this matrix, we will get our message. MATLAB programming. MATLAB directly solves the standard linear programming using slack variables. MATLAB is all about linear algebra. One can perform any operation on matrices and derive the result very fast and efficiently. Thank you.